This is the final image. In this video I will walk you through how I made it using two different algorithms. So last year I made this fun little algorithm. It's actually pretty simple. Here's how it works. You pick a random point on the image and draw a circle around it, as large as possible without overlapping any other circle or until it exceeds a max radius. If there's no space, it gets skipped. Then the circle gets its color from the pixel it spawned on. To save some time, I use a grid, which means that instead of checking every other circle for an overlap, which would be quite slow, I only check those in neighboring grids. And despite how simple it is, the result looks really nice in my opinion. The next step is edge detection. I used something called the Sobel Operator, which is a pretty popular technique in image processing. You have probably seen it before. It makes images look like this. The core idea of it is to find edges by comparing the brightness of neighboring pixels. If there's a strong contrast, it's an edge, which in this case just got colored white. This works by using two 3x3 matrices called convolution kernels. Each one of them checks brightness changes in a specific direction. Gx detects horizontal change and Gy vertical ones. First, to get the brightness, use the grayscale image, where you can just use one of the R, G or B values as the value. You multiply each pixel's brightness by the matching kernel value and add them together, which gives you a number. The bigger the absolute value of it, the stronger the contrast. You do this separately for Gx and Gy and then combine the two by using this formula. Does this look familiar? It is just the Pythagorean theorem. But why? Because Gx and Gy can be thought of as the x and y components of a vector. The magnitude, which is calculated using this formula, is the length of the vector. The longer this vector is, the stronger is the edge. Now if you want to actually display it, you can simply compare this edge strength to a threshold value, and if it is bigger, color the pixel white. In my case, I skipped the square root and just cubed the threshold instead to keep the shader faster. Also, how the kernels determine a brightness change is pretty simple as well. If we take Gx for example, it has these three values on the left side and these three on the right side, which means that if the right side is much brighter than the left, the sum of Gx is positive, and if the left side is brighter, the sum of Gx is negative. So a higher value means a stronger change and a lower one means less. The same is true for Gy, just 90 degrees rotated. But there's one more thing you should look out for. Before running the Sobel operator, the image should be blurred. This prevents the appearance of small edges you don't actually want in the output image. And the cool thing is that this blur is also done with such a kernel. A simple box blur just uses all ones. The generally considered better Gaussian blur uses a formula to calculate the values. For 3x3 matrix it's this. In a blur, the result simply gets divided by the sum of all the values in the kernel, in this case 16. So now I had two separate algorithms, the circle image and the edge detection. Combining it is pretty simple, though I did not use any blur for the edge detection this time, as the edges are quite clear. This does not really work yet, it's impossible to recognize anything. So instead of drawing the edges white, I just used the underlying circle color. I do like the result. That's it. Let me know what you think, and if you're curious, the code's in the description, though it's a bit of a mess. Anyway, thanks for watching.